It's another mains 2021 question related to differentiability and continuity. See here, the function f of x is given as minimum of x minus step x and 1 plus step x minus x. Here step x is usual greatest integer function, and f of x is a function whose domain is the closed interval 0 3, whereas the range is all the reals, codomain is the reals. Okay, see, just identify this domain first. That means in this particular region of the domain, in this particular range of x, we need to analyze the minimum of these two. After analyzing the definition of f of x, P is the set of discontinuous points of f of x, and Q is the set of non-differentiable points. After that, we need to mention sum of number of elements in P and Q as our answer. That's our task at the end. Okay. To find discontinuous points as well, non-differentiable points for f of x, I am going to analyze the function first. And the function is minimum of x minus step x and 1 plus step x minus x, that is given. So for that, what I do is, first of all, think about x minus step x. So we know that step x is a greatest integer function, and this flower bracket of x is the fractional part of x, and we know x is simply nothing but step x plus fractional part of x, and so x minus step x is simply fractional part of x. Is it right? Since x minus step x is the fractional part of x, then the given function f of x is nothing but minimum of x minus step x, means minimum of fractional part of x, and this is 1 plus step x minus x. See, x minus step x is fractional part of x, step x minus x is 1 minus fractional part of x. So step x and 1 minus fractional part of x. See, fractional part of x, 1 minus fractional part of x. Among these two, minimum is the required function f of x. Okay. Okay. This is the definition of f of x in terms of fractional part of x and 1 minus fractional part of x. See, to fix or to identify the minimum among these two, I am just using graph as a tool to answer this question. So for that, I am going to sketch the graph, and on that graph I need to pay attention only in this 0 to 3 region. Okay, so 0, say somewhere we have 1, and then we have 2, after that we have 3. Okay, in between 0 and 1, here somewhere 1 by 2, and here we have what? 3 by 2, and then this is 5 by 2 are the points of x-axis. And one more thing, fractional part of x. Always fractional part of x lies in between 0 and 1. I think you all know the basic idea and the basic definition related to this fractional part of x. Is it right? Fractional part of x means it's the decimal value or the fractional value of a function. Always its value is in between 0 and 1, right? So fractional part of 3.78 is 0.78. I think you know. Fractional part of 1.54 is 0.54. Is it right? Right. And so the results, the graph is always lies in between 0 and 1. And see, in between that 0 and 1 we have 1 by 2. So now I am going to sketch the graph of fractional part of x, and then I will sketch the graph of 1 minus fractional part of x. See, fractional part of x acts like x in the region 0 to 1 because its values are just 0 to 1. At 0, fractional part of x is 0. At 1 by 2, fractional part of x is 1 by 2. At 1, fractional part of x is again 0, but in between 0 and 1 the graph almost approaches like this. Then in between 1 and 2, what will happen? In between 1 and 2, I am going to sketch the graph of fractional part of x. That's it. Okay. In between 1 and 2, again the graph of fractional part of x will be like this only, right? This is the graph of fractional part of x. Why? Because at 3.2, just think about it. I think you all know fractional part of 3 by 2. Fractional part of 3 by 2 is 1.5. Fractional part of 1.5 is 0.5 again. So at 3 by 2 again the value is 1 by 2 only. So likewise, for every value in between 1 and 2 gives us same result as in the between 0 and 1. Again in between 2 and 3, again the graph of fractional part of x will be like this only. At 5 by 2, again it is 1 by 2. So basically this is the graph of fractional part of x. And now I am going to sketch the graph of 1 minus fractional part of x. For that I am going to use this red marker, okay? 1 minus fractional part of x. At 0, the value is 1. Okay? At 1, the value is not exactly 1, it is approaching to 1. At 1 by 2, again the value is 1 by 2. See, in between 0 and 1, this 1 minus fractional part of x graph will be like this. Here you need to maintain open curve. Okay? Yeah. At 1, what will happen? Fractional part of 1 as well as fractional part of 1 minus 1, both are zeros and the minimum of those two is z, simply 0. Okay, again I will discuss. And in between 1 and 2, what will happen? In between 1 and 2, the graph will be like this. Yeah, at 1, fractional part of this value is 0, 1 minus 0 is 1. So again I need to start with this red mark, and then this is the graph of this 1 minus fractional part of x. Okay, and again at 2 I need to fill this, and this is the graph of what? 1 minus fractional part of x. Now this red color lines indicates the graph for the 1 minus fractional part of x, whereas this blue color lines indicates the graph of fractional part of x. But always I need to identify the minimum of these two. While identifying the minimum, I am just highlighting this. Just have a look. Okay, I am just marking like this. This is the graph actually what we need, because since we are identifying minimum, right? For suppose in this region between 3 by 2 and 2, what is the minimum point? This blue red color line is the minimum, right? So highlight this. In between 2 and 5 by 2, this blue color line is the minimum, right? Highlight this. Highlight this. So whereas this green color shaded part is the required graph of this f of x. When you observe this green color part, what happens? When you observe this green color part, one thing is very clear, the graph is clearly continuous. No breaks are involved in this graph of this minimum of a fractional part of x and 1 minus fractional part of x. The graph is clearly continuous. Since the graph is clearly continuous, so it has no discontinuous points. Since P indicates the set of discontinuous points, number of elements in P is just 0. Whereas now you need to think about what? You need to think about non-differentiable points. See, sharp corners are the reasons behind the non-differentiability. I mean, sharp corner is one of the reasons behind the non-differentiability. So I am going to identify the sharp corners in this interval 0 to 3. Just have a look. This is one sharp corner. This is the other sharp corner. And this is the third one. And this is the fourth one. And this is the fifth one. So finally we have, see, 5 sharp corners in this region. Okay, so in this closed interval of 0 to 3, there are 5 sharp corners. So the graph is for sure non-differentiable at these 5 points. So the number of elements in the set Q is 5. Number of elements in set P is 0. Number of elements in set Q is 5. So our task is to find the sum of number of elements in P and Q. 0 plus 5 is equals to 5, and that 5 is our answer. Okay, have a look.